Hi, welcome everybody to this new meetup, Pyladies meetup. I see new faces. Then we are going to speak really short about Pyladies and what we have done during 10 years already. Okay, Pyladies Barcelona, born as part of PyBCN. I don't know if you have been in the general meetup about Python community in Barcelona. Then Pyladies started in PyBCN because Laura and me were alone in a wall full of men in tech, and we want to know more women in tech because there is some. It's hard to find them, but exist. Yeah, you can see. It's really nice to have one of tech events in Barcelona with mostly women as attendee. You have to hack it a little bit, but I think it's okay. It's for the community. Then, as I said before, we are working hard during 10 years. We started at 10 years ago, and now the meetup is about 900 members, only Pyladies. Okay, PyBCN is about 3,000 or something like that. Okay, every interesting event, it's increasing the number of attendees. Then thank you for help us to grow. And just some photos about what we have done. If you, it's not just the meetup, we organize monthly meetups and Django sometimes some special events. And feel free if you have an idea, crazy ideas or something new, you can contact us and give us ideas. We are going to try to make it possible. Okay, trainees, hackathons, I don't know, whatever. Feel free to contact us and we make it possible, probably. Okay, and yeah, what is the future this year about Pyladies?
We will try. This year we will try to do some Py beginners, or we want to visit the new computer in the BCN. We will do a summer edition and more Pyladies talks. What else? Yeah, already Nuria talked about the monthly meetups we do with the PyBCN Association, and well, several other events like the Pi Day that are also organized by Pyladies and PyBCN, and a lot of photos of the different Pi Days we have done. Yeah. And please join us to the next meetups and to the next Pi Days and different events. If you want to collaborate with the PyBCN Association, you can become a member. You can propose a talk or do a workshop. You can also volunteer in the different events like Pi Day or sponsor us. And also, if you join the meetup, you can also receive the job offers that we send. Yeah, that's it. We will introduce our first speaker, that is Idoia from Adevinta. Give a warm welcome, please. Turn it off.
¿No? Vale, súper, gracias. Well, thanks for this warm welcome. Well, my name is Idoia, and well, tonight we are going to talk a little bit about, well, we are going to do like a masterclass in terms of, to try to analyze if there is gender gap in real life by using a real data set. So I'm going to show you some code that is already defined, and we are going to dive into it, okay? We are going to see not only if there is, let's say, this real gender gap, but also see a little bit the fundamentals of data analytics, which is my expertise. Okay, so this is my name because I know that it's a little bit complicated. If you want to find me on LinkedIn or whatever, contact me. Just feel free to send me an invitation. Right now, I'm working at Adevinta, which Adevinta is a global classified specialist, and basically our products are like different sites and market leading positions, no? And basically, what we are doing is, providing or connecting buyers and sellers and helping people finding jobs or finding their cars or their houses and so on, okay? And I'm going to introduce you a little bit about Adevinta. So basically these are like our brands all over the world. We are like operating in 10 countries. We have like more than 25 marketplaces, and those are like the brands that we have, no? For the ones that we are here in Spain, you will be familiar with, for instance, InfoJobs, Fotocasa, Cochesnet, Milanuncios, Habitacle, and so on, but there are like more. For instance, in France, we have Leboncoin and so on, okay? A little bit about numbers, because I come from data, so I really love numbers. So just to let you know that, Adevinta, our websites have like more than 2.5 billion visits worldwide, which is not that bad, I would say. We have, as I was telling you, more than 25 digital marketplaces. This is the revenues, that it's something that is also important, no? And this is the amount of employees that we have all over the different countries, okay? And after this brief introduction about Adevinta and what are we doing at Adevinta, let's talk a little bit about numbers indicating by gender, okay? So this is just some headlines, no, that I found out on the website, no? And we can see that only 1 in 4 students in STEM courses are women, okay? This is one, reality, no, that we can see. And also if we are moving into the professional sector, so if we are moving in the tech field, we can see that only 1 in 5 workers in the tech field are women, okay? I don't know if you have faced this issue, but I've been working in the tech field, and we can see that I was able to see that it's some kind of reality, no? So there is not so many representation of women in the tech field, okay? Gender gap, so these numbers or these headlines that I was pointing out, they could be linked to gender gap, and I want you to interact with me a little bit and just put your thumbs up or down whether you see that that there is like a gender gap in the tech field specifically, just to see a little bit the introduction, if there are a lot of thumbs up or thumbs down. I can see that, the thumbs up are a little bit the majority, unfortunately. Let's zoom in a little bit, not only on what we see here and what we all here in this small community think about it, but let's see if the society also thinks that there is a gender gap. We can see that, here what I did is to post some pieces of news from different newspapers. I don't know, the New York Times, Forbes, The Guardian, and so far. All of them, can you see that, they have some headlines and some news regarding gender gap, no? So that means that at least for the society or for the news, in the news section, somebody's interested in this kind of field, no? But the point is that, okay, we have this information and you can zoom in and have a look at it, but is it real, this information that they are showing us? Because we know that sometimes in the news, no, the information comes a little bit biased, no? So to achieve this goal, what I did is to prepare this notebook in Python and analyze real data, okay, with Python to see if, this gender gap is reality, no? To have some arguments and to have some information about, real information coming from our sites, no? To see if it's real, okay? Because, basically this is what we are going to do, okay? And now, if you don't mind, what I'm going to do is to, I don't know, can you hear me or see? No? Vale. What I'm going to do is to switch into, a notebook, okay? So this notebook is already closed, and basically what we are going to do is have a look at it, okay? Okay. Okay, so basically what I did is, okay, you know that finding data is sometimes difficult, and finding data regarding gender, wage gap, salary gap, it's almost even more difficult, okay? So I was kind of seeking and going like crazy and trying to get in that data, and basically I was not able to find so much information. The only website or the only place in which I was able to find some information is the Bureau of Labor Statistics. I don't know if any of you is familiar with that, yeah? So basically it's, for the ones that don't know it, it comes from the states. So people from the states have a lot of things, but one of the good things is that they are sharing everything in terms of data, no? So this is a federal organization that basically what it does is, share all the information, so collect some data from different people and from different sectors, but also share that data and do some studies regarding that. Among them, one of the things that, you can have a look at it is some annual report regarding women's earnings, okay? So basically you have different information coming from different years. Can you see that it's starting from 2015 up to 2022? And basically what I did is to download this Excel file, which is that one, a really big one, and it contains a lot of information. And in order not to extend this masterclass or this talk, what I did is to go directly to this table, but can you see that it's also split by state? So you have a lot of information. So if you want to have fun and you want to, create a dashboard or do something on it, just go on that website and, you can get beautiful insights. So what I did is to directly go to that specific Excel file. Let me zoom in. And basically that one, what it contains is, all the different occupations, the total number of workers that they were asked on 2022, and also different information coming from those workers. Okay, so basically what they were asked is whether they were women or men, or male or female, but also the median weekly earnings. Okay, in the States, I don't know if you are familiar, but normally they receive the salary per week, no? So they have a weekly income. What does the median means? So we know that, if there are 20 people working on the health system, each one is not going to have the same salary, okay? So each one is going to have, let's imagine that it goes from 0 up to 100. So the median, it will be the value that it's in the 50% position. So the median value will be the 50%, okay? Because we know that, for instance, maybe it's not the same to work in New York, that is a city and it's super expensive, rather than in a really small country, no? On a really small city, sorry. So in order to have a value that could be representative, what they did is to get the median, okay? So based on that, can you see that we have a lot of wealth management, chief, natural sciences, and so on. It's a really long list because there are a lot of different professions and occupations. What I did is to clean it up a little bit and transform all this super big list into an kind of group, no? And transform this list into a small data set that it's called, which group information, okay? So based on that, what I did is to get that information and have this small data set, okay, in order not to extend and to be kind of easy. In that data set, we have, this amount of different occupation and these columns, okay? We are going to have a look at it, okay? So this will be our base data set that comes from the Excel, from the Bureau of Labor Statistics, okay? And this is what we can start now. So basically, the first thing that we have always to do when doing code, it doesn't matter if it's Python, CSS, Java, whatever, it's to import our libraries, okay? Basically, in data and data analytics, we normally use pandas, okay? Pandas is like our best friend, let's say pandas, no? We normally work with pandas, and all the data transformation and all the different things that we are going to ask to the data are going to be done with Panda, okay? Apart from pandas, we are going to also import, those are like libraries that are linked to plots, okay? Because any analyst that works with data also needs to plot something. Why? Because In my case, I am familiar, and maybe you are familiar with numbers, but the audience sometimes is not familiar with numbers, and the audience, thinks better, or it's allows or kind of understands better the problem with a plot. Okay, I'm thinking about my mom or my whatever, my dad, etc. No, so people that are not familiar. No, if you want to show something to a client, it's more powerful to show a plot. Okay, that's why what we are doing is also importing some libraries. Okay. So let me execute that first code. And once the libraries are already imported, what we need to do is to import the data. Okay. This is PD is the pandas is the abbreviation of pandas. So we are going to use one method that it's called read CSV, which basically what it does, import a CSV file. What does it mean a CSV file is comma separated values. So that means that all the different values that we have for all the different rows are separated by a comma. Okay. So if we are importing that specific data frame, the one that I was showing you, and we are just showing how it looks like, this is how it looks like. So we have already the data that we show in a TXT file in our space, okay? So the first thing that we have to do is not only import our data, but as a data analyst is like, okay, let's check that everything looks fine. So the first thing is normally what we have to do is ask or try to let's say, ask some questions to the data, because what we are going to do is try to answer those questions, always based on the business approach, okay? In our case, our business approach or our business understanding, which one is it, okay? Is there any real gap in terms of gender? Okay, so the first thing that we have to do is always check some technical things. No, first of all, the entries that we have, the columns. Why it's important to ask these things? Because maybe we don't have enough information. Okay, imagine that we have only 3 rows. It won't be representative of the problem that we want to see. No, okay, so that's one thing. Okay, we have enough information first of all. So one of the things that we can do is, well, from this data set that this is an object, a data frame object, is to extract one attribute or one property that it's called shape, that basically what it shows us, the shape, okay? So the amount of columns and the amount of rows, okay? Like typical ones like in math, no? So it tells us that we have 18 rows, so 18 different occupations and 6 columns in that case, okay? There is another super powerful method in Pandas that it's called the info method, that one. That, well, it's super powerful and it's really used for people working in data, which is the info method that, as its name say, it tells us some information regarding the data set, okay? So it shows us like a summary of the table, and basically in that summary it shows us, on the one hand, so range, so how many entries do we have, okay? So how many rows do we have? So it tells us that we have 18 rows. And also it's telling us some information regarding the columns. So this is like a table that it summarizes all the columns. So we have column 0, this is the name of the column, which is called occupation, and this is the amount of non-null integer, non-null thing. So this one, what it's telling us is whether we have null values or not null values. Why? Because if we have, imagine that we have all that information in our data set, but everything is empty. Okay, we can have like 18 rows, but everything is empty. This column is not useful for us. Okay, so what we need to do is maybe drop this column or talk to the client or try to find a new source, no? So in that case, we have 18 entries and 18 non-null values, let's say. So that means that this column is completely empty. Same for all the different columns, all workers, M workers, F incomes, M workers, and income, okay? The last column is also super useful, really interesting for us, okay? So it tells us the type of column that we have, because we can have numerical columns or categorical columns, text columns. It's not the same. If I want to calculate the mean, if I want to calculate something or a ratio, I can only do it with numbers, right? Because with text is impossible. We cannot calculate the text, no? So every time that we have int or float, it tells us that it is a numerical column. And when it tells us object, it means that, well, it contains text on it, okay? So it gives us some clue. If, for instance, imagine that here, rather than have, so this is all workers, no? The amount of workers that we have, an integer, we have, for whatever reason, object, it will indicate us that there is something wrong in that column. So for whatever reason, somebody typed something, like an A or a B or whatever. Okay, in that case, everything is pretty clean because I was I was cleaning it before, but in real life, normally it's not like this, you know. Okay, so and also last thing is like, okay, in the last line, it gives us the total amount of columns that are integers. So we have 5 numerical columns and 1 categorical columns, okay, object, no? Now, in that case, it's super easy because it's a really small data set, but imagine real life in which we have maybe 100 columns, okay? It's kind of crazy to go one by one, no? So with that one, we can have like a summary, okay? So linked to that, the second technical question that we have to ask is whether we have missing values because of that, okay? So missing, we don't want to have missing values because the information is missing, okay? So if the information is missing, what shall we do? There are like different strategies. You can fill with the mean value, with some information that we already have. But if the data set is completely missing, so the information is missing, what we have to do is, okay, get a new data set, talk to the client, talk to whoever has provided this information because maybe something happened on the go, okay? So you can check the missing values here, but also there is also different ways, okay? So there is one way that one method that it's called is null, that basically what it does is providing us the null values that we have, okay? And if we append also the sum method, what we are doing is summing the null values that we have in our data set, okay? So if we are executing that cell, basically what it's doing is giving us that information. Why am I appending this sum value, which is 0? Because if I'm not appending that one, what I'm going to get is like a Boolean, which is nice, no? False, 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 false. But I mean, it will be kind of hard to count how many truths do we have and so on, okay? So if we want to, let's say, just see the amount of null values, overall speaking, what we can do is concatenate that method and get this. So it's summing the true values, okay? So those are like the first thing that we have to check. So check the shape, check the information that we have, whether the variables are kind of okay. So if we have an age variable that is a numerical and it's numerical and so on, and also the null values. Once we have solved these technical questions, that means that our data set is nice enough and it contains nice information, let's meet the data and try to ask some questions to our data set. Okay, first of all, do we have duplicates? We need to see if we have duplicates because, okay, if we have duplicates, the insights and the information that we might get from the dataset is going to be wrong, okay? Because it will be repetitive information. It will be like Agent Smith from Matrix, you know what I mean? So it's not enough, no? So how can we get that information? So you will see that Panda is pretty intuitive. So here what we are doing is also using one method that it's called duplicated. That basically what it shows us is, well, it shows us the duplicated values that we might have in our data, okay? So if we are appending also this sum method, what we are going to get is the sum, okay? So we're going to get a number that will indicate how many duplicated entries we are going to have, okay? In that case, it's also 0. That data set is super nice, okay? More information. Now we can dive into the different columns, no? So the occupations, which was like the first column, no? The column that was giving us information regarding the different occupations. How many occupations can we find? In that case, it's easy because we have like only 18 entries, but if we have a really big data set, it could be the case that it could be repeated, that one. So one of the things that we can do is use the method unique, okay? The method unique, it provides us the unique elements that we have in a column. Why I'm telling you a column? Because we are appending occupation, okay? So it's like unique method applied to the column occupation that comes from the data that is our original data set, okay? So if we are executing that statement, what we are getting is an array with the unique occupations that we have in our data set. So in our case, we have management, business, software, engineering, science, and so on, okay? That's a lot, no? It's a lot of them, and well, in that case, well, we can read it because it's not that complicated, but if we want to see how many different occupations do we have, there is another method that it's called nUnique that counts the unique occupation. So it counts the total amount of occupations in that case, no? So in that case, what it's going to give us is 18. Those are like checks that we can do with the information that we have from the client or from the stakeholder or whatever. 18 matches with the number that they were giving us. Yes, okay. So let's move on. More things, okay, the variables that I have. We saw it briefly. This is, rather than a method, we are going to extract a property from this object, okay? This property is called columns, that it basically what it does is providing information regarding the columns, okay? And here we have this information. It's kind of repetitive, but it's a thing that we have to do. So we have, on the one hand, the occupation, which is the job, okay? The second column, which is called all workers, it contains the total amount of workers that will answer in this specific survey. Then we have F workers, which contains the total amount, from the total amount of workers, how many of them were female, the income that those female workers have. Sorry. Many things there. Yes, and also, well, same information from male workers and male income, weekly income, okay? So based on that, this is some information that we need also to receive from the client, from the stakeholder. It's not something that sometimes some variables it's easy, no? You can understand or you can get the meaning, but some of them, you need information from them, no? So once we have that information, we can go directly to let's say, to explore this wage gap, okay? So we have the information coming from male income and female income. Another thing that we normally do as a data analyst is to calculate things, calculate ratios, differences, and so on. Why? Because, well, it's easy for us, or it's one thing that it's called feature engineering, so getting new features from the ones that we have, because otherwise, sometimes the analysis is kind of small and we need to expand a little bit, no? So one of the things that we can do is like, okay, let's see which is the gap, no? So let's calculate or create a new variable that basically what it does is, okay, subtract subtract male income minus female income, just to see, well, which is the difference between them, no? So according to that, so the closest to 0, the smaller the wage gap will be, right? So that means that if for males it's 15 and for females it's 10, well, the closest to 0, the better. Okay. So one of the things that, well, that's how we can do it, as simple as that. So just subtract as it is and, well, save the information in a new variable that it's called gap. Okay. So if you are executing that cell and getting that information, we are getting a new column that is called gap. That's basically what it's doing. What it's showing us is this information, the gap, which is the difference between, well, in that specific occupation, which is management, which is the difference between the median income from the males versus females. Okay, so we have 400, blah blah blah, and a lot of information that we are going to see it later now. Okay, so based on that, if we are analyzing that specific formula, if we have that females in any occupation earn more than males, that means that, well, this gap column should be a negative value, no? So let's see. Do we have negative values in our data set? What do you think? Thumbs up. So that means that more women earn more. So the only thing that we have to do is apply that condition, okay? So that condition, which is gap smaller than 0, and no. Unfortunately, this is not the case. Okay, I don't know if it's surprising. For me, it was not really surprising. Okay, so based on that, well, let's see. Okay, maybe it's not 0, but maybe it will be 1, no, which is acceptable. Let's say, no. So one of the things that we can do is like, and normally as a data analyst, what we do is not only analyze the numbers. Is what I'm telling you. Okay, create some plots, no. One of the plots that, well, I'm going to show you is one that it's called funnel plots. Okay. Those type of plots, basically what they are showing is, okay, for different categories inside one categorical variable, so one text variable, well, showing the percentages or some numbers, and what we are doing is getting some kind of order, right? Okay, so basically it's called funnel because it has this funnel shape in which basically on the first line we have the one that has more counts or more percentage and so on, okay? So this is what we are going to do. First of all, what we need to do is, let's say, sort the values. So I'm using this specific, because here can you see that it was just let's say from row 0, this is the gap and so on, but we don't have the information sorted using the gap. So basically what we are doing here is just sorting the gap, okay, and see what's going on, okay? Sorting the gap and showing just the 2 columns that are more interesting now, okay? Because visually speaking, it's easy to read something like that rather than have a lot of columns in between. So basically here when I'm subsetting only occupation and gap. And this is what we have. So we have for the legal department, so people that are working in the legal, the gap is 852 per week. Per week, eh? Per week, followed by management by 400. This was very impressive when I was saying, because I was like, I was expecting management, but legal and that amount, that means that 800 per 4, so per month is $3,000. A lot, eh? Followed by management, software, blah, 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 and so on, okay? So this is the information that we have. And okay, we have that table, but let's transform this information into a funnel plot just to see how it looks like, no? Because presenting a funnel plot to somebody that is more powerful always, no? So I'm really fan of one library. One library that it's called Plotly Express. Okay, I don't know if any of you is familiar with Plotly Express. Normally, well, people tend to use Seaborn, Matplotlib because are like the most simple ones. But well, Plotly Express is a library that allows us to create interactive plots in an express way. That's why it's called Plotly Express, okay? And it's really easy to use, and the syntax is not really complex, and you can create really powerful plots in a super simple way, okay? The only drawback that we have is like, okay, it's interactive, so it weights, okay? So depending on if you want to include it in a website or whatever, well, it's heavier than something plain, no? But basically, in all cases, what we have to do is always, this is the abbreviation of the library, which is called PX, and basically use the method. The method, it means, well, the plot that we want to use. In that case, it's a funnel plot, so it is called funnel, okay? And what else? We always need to include our data set, first of all, which is everything. So that all the information that we have here, everything sorted and so on, and what we want to see on the X and on the Y, and so on, as simple as that. This is just the string, okay? The name of the column that we want to see on our Y and on our X, okay? The other information, which is color, discrete sequence, those are like different things that I'm including in order to make it prettier, okay? But it's nothing really important or very important. It's one way of enhancing and magnifying everything, okay? So once we have that figure that it's called fake funnel, we can use the method show in order to show that method, okay? So if we are executing that one, this is what we are getting. The same information, and can you see that it's more powerful? For instance, the legal one, for me, it's like super powerful. No, you can see that it's pretty far from the second one, which is 400, okay? So something that it's like, and well, at this stage, we can see that, okay, this one is kind of far from the rest, but regarding the rest, it's like 400, 300, which is kind of, wow. Okay, the one that at least in those top 10 is the smaller, it's even, well, $200 per week, okay? In terms of median, that means that there is people with more and less, you know? But bueno, this is what it is, okay? So based on that, okay, now we have seen the ones that in which there is no equality. So let's see the ones that are like more equal. In that case, what I'm going to do is exactly the same, but showing you the ones that are, let's say, the gender gap, the gap is smaller, okay? And this is what we have, okay? So we have, on the one hand, social services, but the gap is still 100 per week, okay? Followed by office and administrative, building, science, personal care, construction, and so on, okay? Let's turn also this information or this table into, well, following the same approach into a funnel plot just to see how it looks like. In that case, can you see that, well, those top 10 are not that different, let's say, in terms of number, and well, maybe the plot is not really as powerful as the previous one, okay? Because it's important always not only to create plots, but also to select the ones that are more suitable to impress the audience, always, okay? But you have to, sometimes you have to test and you have to do some, let's say, experiments, no, with your data and plots and so on, okay? So we answer those questions. There is wage gap in terms of gender, right? Based on that, let's see, okay, we can see that in the legal, no, there is a lot of difference between what females and male earn. So second question that we might be asking, okay, which are like the first position in which we can find more women? Because maybe it's because, I don't know, there are not so many women or whatever, no? So one of the things that we can do is also use the method that I was telling you before, that it's called sort values, but in that case, instead of sorting everything using the gap variable, what we are going to do is using the variable that it's called female, okay? So if we execute that cell, what we are getting is, well, this number, okay? We have management, 27,000 workers, followed by sales, office, and so on, okay? A big curiosity that management is, let's say, the one that has more female workers, and it was on the second position, right? So it's a little bit sad, but like life is like this, no? As well, we have this information in numbers. We can transform this information into another plot, okay? One of the most common are bar plots. I don't know if you are familiar with bar plots. I believe that with COVID and so on, we were all super familiar with a lot of, seeing a lot of plots everywhere, no? But bar plots, basically, what they show is similar information as funnel plot. But in that case, rather than, let's say, showing the information in a funnel way, what we are doing is showing the information or the counts for each of the different categories in bars, as a bars, okay? And just to show you, this is the library that it's called PX, Plotly Express, and in that case, what we are doing is using the method bar to plot the bar plots, okay? So as simple as that. Same, what we need to do is first of all include the data that we want to plot, followed by what we want to see on our X and our Y, okay? So we are getting that information, this is what we are getting, okay? A really, well, powerful plot as well. Okay, so in that case, visually speaking, you can see also that there is, well, a super big difference between the first occupation and the second one, okay? So it's really powerful. Let's do the same, but the ones that, well, that are in which there is less representation about women, okay? So if we are extracting the tail, so the ones that are on let's say, on the tail of the data set, we can see that it's like construction, engineering, primary sector. But we have science. We have also software here. Okay, so it's telling us something that we were kind of boring before regarding the gender gap. Okay, let's do the same, and in that case, get that information, which are like the bottom female positions in which we can find less females in a bar, just to see how do they look like, and it's kind of similar. Okay, so construction, engineering, science, and software. It's a little bit, it's a pity, but it's corroborating our statement, no? Our hypothesis that we had at the very beginning, okay? Vale, this is what we have. We have like, so you have numbers, okay? We have, but sometimes it can be difficult, no? To compare this 1,500 something with the 200. So one of the things that we really love as a data analyst is to create new variables. So one of the things that we can do at this stage is to create some ratios, okay? So that means that, which is the percentage of female workers in social science, in software, and so on, in order to see something kind of better. Why? Because maybe, I don't know, we can analyze that data coming from a different year, and we have, we can compare, let's say, we can compare 2021 and so on, okay? So this is what we are going to do, okay? Divide the total amount of female workers by the total amount of total workers, okay? So we are creating this variable, okay? The variable that's going to be called F ratio. And basically what we are doing is dividing, well, what I was telling you, the female workers by the total one, okay? Always, every time that we are creating something new, we need to check whether if it makes sense, okay? That's why every time you will have like a data head or whatever, just to see if it makes sense. And this is what we have, okay? So we have the representation, so the percentage. So that means that, and it's kind of easy. If you are going with that number to your mom or to your dad or to your sister or whatever, well, he or she will be, okay, I understand. 50%, 51% of the total workers that are in the States, in the management field, are female. It's easy, rather than 20,000 K, blah, blah, blah. No, it's kind of difficult, okay? So in that case, what we are going to do is, rather than using this absolute number that we were saying before, use this ratio, okay? Because then will be kind of easy, to see if this 27 is representative of the population and so on, okay? So what we are going to do is repeat the same procedure, so create let's say, sort the values that we have in our data set, but in that case, using the ratio, and plot them using a bar plot, okay? So those are like the top 10. So the top 10 sectors with more women working on it. And can you see that the first one is healthcare services? It used to be management on the previous plot because we were using only the value. We were not comparing it with the total amount of workers. Okay, the scenario is kind of different, right? Unfortunately, we have healthcare, personal care, education, office, social services. Surprising? All right. And this is what we have. Okay, and these are like the typical sectors in which you can find more women working on it, right? So personal care and so on. Okay. Let's repeat the same procedure, but in that case, rather than using the top, the bottom, okay, considering the ratio. So basically, let me go directly to that one, to the plot. And basically, in that case, it's kind of pretty similar. So we have construction, primary sector, but we still have engineering, but we also have transportation, production, which is something that also kind of makes sense, no? Kind of makes sense, but we have also software, engineering. So those are like this gender gap that we were talking about. Well, it's reflected in these numbers, okay? And so one of the questions that I was like, okay, considering these specific plots, why do we have so few women in the engineering and tech field, no? So one of the things that I was asking is like, okay, why? It's because, well, we were told that we were not good at maths for whatever reason, no? Because, I don't know, it's something that it comes from whatever. So basically what I did is to try to find some answers regarding this information. So we are not good at maths, or it's something social. What's the best thing that I found in order to try to answer? So I don't know if you're familiar with PISA program. So PISA is one let's say, some test that they do into 15-year-old kids, and girls and boys, into different subjects: math, science, reading, comprehension, and so on. And basically what I was doing is, well, what they do is, well, perform some kind of test and evaluate the performance based on the different countries and so on, okay? So what I was doing is diving into the website and getting information from the different maths and science score, split by gender and by country. And what I did is, well, get all that data and put that data in, well, I create my data set using that information, okay? So the data set that I'm going to show you is that one, okay? Is that one, okay? Basically what it has is, well, the indicator which indicates as whether the exam it was math or science. Okay, we have also reading and comprehension, but it's not the interest of this talk, but if you want, you can have a look at it. And well, if it was a boy, and basically what we are getting is the mean score in that case, so the mean value, considering, well, different years and different countries, okay? Because this is the information, this information is public, you can get there and so on, okay? So I was able to get that information from different countries, different years, different genders, and also different subjects, okay? So what I was doing is, okay, getting that information and, well, let's try to analyze that data to see if, okay, those are like kids from 14, 15 years old, let's see if there are like differences, because maybe it's something genetically or something that, well, whatever, no? So let's import that data and let's double check that everything is kind of okay. Can you see that here we have, well, it's a longer data set, okay? Because we have different years, different countries, and it's a little bit more complex, that data set, okay? In principle, everything seems to be fine, no? So everything seems to be, visually speaking, everything seems to be kind of sorted, and no, there are no like weird things and so on, okay? But let's repeat the technical questions that we were saying before, okay? So first of all, the entries that we have, okay? So the entries, so in that case, we have 1,185 rows, so it's a big data set and 7 columns. Okay, so this one is a little bit more complex. Let's check whether we have missing values, because can you see that here is impossible to manually or to visually in a manual way see whether there are like nulls or nones or whatever. So to do so here, we're going to use the method that I was telling you before. So summing the null values that we have in our data set. And in that case, we can see that for each of the different columns, it is 0. So that means that it's a clean data set and a really nice data set. Okay. Another question that we were asking, okay, the duplicated. Here, it will be nice to see if there are like no duplicates. So we are repeating the same procedure. So getting the duplicate, 0. So that means that all the data set is pretty clean and so on. Okay, so we can move on. Okay. In that case, let's have a look at the columns, the indicator, which was telling us the type of subject that we were discussing. Okay, so we are getting, so if we are extracting the unique, what we are getting is PISA math and science. So that means that we have all information from maths and science. That's nice, because maybe we have all the information that is not missing, but all of a sudden there is something linked to reading or whatever. Okay, we are not going to use that one. Okay, more information. Okay, we have maths and science, but is it kind of balance the amount of information that we have for maths and for science? Because it could be that, I don't know, maybe we have just 2 entries for maths and the rest are for science. We cannot further move on the maths. So one of the things that we can do is to create one thing that is called frequency table. I'm in love with frequency tables. What it tells us is, well, how many frequencies, or it counts us the amount of entries that we have for the different categories. No? For instance, in that case, if we are calculating the frequency table of indicator, it's going to show us the amount of entries that we have for maths and for science. Okay. This method, this can be done by using one method that is called value counts, that it counts the values. So pandas is pretty intuitive. So just with a little bit of common sense, you can kind of guess, no, a little bit the meaning. So here we have that. We have 625 entries that are coming from maths and 560 from science, okay? In that case, it's not 50-50, but I mean, the difference is not kind of drastic, no? This is something that, well, you have to check, because imagine that you want to also analyze something coming from genders, no? And you have only two women and the rest are male. Okay, you cannot get insights with just 2 entries. So it's impossible. So that's one of the things that we have to do. Okay. Now that we have that all the information is kind of, let's dive in. Okay, so let's zoom in into just maths and to just science. Okay, so let's start with maths. So first of all, what we can do is subset, no, and just get the information that comes from maths. Okay, so here what we are doing is creating this with this condition that basically what it shows us is, okay, subset all the rows in which indicator equals to math, okay? And I'm going to save that information in a new variable called maths in order not to get lost on the way, no? Because otherwise it will be kind of difficult. So here, can you see that we have also maths, boy, blah, 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 and so on, okay? Now that we have the maths, let's see if we have enough representation about boys and girls, because it's like, okay, we have subsetted just the maths, but maybe everything is linked to girls or boys, no? So we are going to repeat and get that information and get a frequency table from this subject, which is the gender. And here we can see that it's pretty equal, okay? So we have the same amount of maths answers for boys and girls, which is nice. That means that we can move on, okay? And so on. The timeline is another thing that we can, well, based on that to see, no? To see how many different years do we have, just to see if it's representative, no? Because maybe, I don't know, if you have just 2020, which belongs to COVID, maybe it's not representative of the society and how everything evolves, no? Because all the kids and everybody was kind of weird, no? In that year. So if we're extracting the unique values, you can see that we have 2003, 6, 9, 12, and so on, okay? We don't have COVID times because everybody was at home, so they were not going to school and so on. And we can continue asking questions. This is something, a never-ending story, you know what I mean? Is some people get, there is another expression that is called paralysis by analysis, because some people tend to analyze, and sometimes it's like, okay, you need to be able to find like a balance between, okay, analyzing the data, but also, you know, being efficient, no? Okay, and going back to that specific case, okay, you can see that we have a lot of information coming from different countries and so on. It will be difficult to analyze these scores. Just to let you know, this is the value of the scores, and it goes from 400 up to 600, okay? That's why you have these numbers, this weird number. We are more familiar with 0, 10, and so on, but bueno, this is how they normally evaluate. So one of the things that we can do is, okay, we have the different countries and different timelines, so create, let's say, or calculate the mean for each of the different years. Okay, let's forget about countries. Okay, we are going to include either if we have Australia or maybe, I don't know, Spain or different countries. Okay, some countries that maybe are like proficient and some others that are not that proficient. So one of the things that we can do is calculate this mean. Okay, so there is one method that it's called group by, that basically what it allows us is to create to group using 1, 2, 3, 11 variables. In that case, what we are going to do is group by subject and time. So that means that we are going to have, on the one hand, girl 2002, girl 2003, girl 2004, and so on. Okay, boy, and all the different combinations. And with these small objects or these small boxes that we are going to split, what we're going to do is calculate the mean value just to see a representation. So that means that we're going to have for each subject and for each year a mean value of this score, okay? And this is what we are getting. This is a summary, okay? We are transforming a little bit the data, and this is what we are getting, okay? For the different years and for the different genders that we have, the mean value, okay? In that case, it's a little bit difficult to analyze a little bit, no? Then these numbers is kind of difficult. Let's transform them again into a plot. In that case, we are going to use another bar plot, which is, this is what we are getting. So in that case, what we can see in that plot is like a double bar plot, okay? So we have on our x-axis, we have the timeline, so the different years that we have, and in our y-axis, what we have is the value. But also we have two colors. So we are going to split also the information coming from boys and girls. So if we have like 3 variables. So 3 variables are split together. And can you see that if we are coming from 2003 up to 2022, I don't know what it's 21, can you see that the difference is? There are no differences, pretty tiny. And I would say that, well, in some cases, pretty tiny. For me, it's not significant. We can do an hypothesis test or whatever, but for me, it's not significant in that case, okay? This is for the maths. Again, those numbers are weird, so we can calculate ratios as well, no? So one of the things that we can do is, well, calculate a ratio, calculate the difference, okay? So calculate the difference between boy and a boy divided by the total, just to see if this difference is big enough, okay? So this is the formula, mean scores boys minus mean score girls divided by the total, okay? So the closer to 0, 0 divided by something, 0. That means that let's say the more equal the scores are, no? The more equal the punctuations are, okay? So to do so, what I did is to create a function, okay? And basically what I did is to apply that function to our data set in terms of the maths, okay? And this is what I did. So this is the differences. Rather than splitting everything into, let's say, into gender, we have the difference, okay? Between the score in terms of maths, boys and girls. And can you see that in all cases, it's pretty close to 0, in some cases 1 point%, okay? Let's visualize again these differences again. So in that case, we are going to use scatter plots, okay? Rather than bar plots, we are going to, let's say, show the information in scatters, okay? In that case, the method from Plot Express is called scatter. Can you see that it's pretty easy? And same, data set, what we want to see on our X and what we are going to see on our Y, okay? Which is the year versus the difference. And this is what we are getting. Can you see that wow, having a look at it, you can see that, okay, if we are just zooming in into the, let's say, into the markers, we can see that, okay, there was something happened, right? Up to starting from that year that it seems to decreasing, no? A little bit. Watch out, because yes, this is a gap, but what about the scale? So if we are talking about percentages, that means that this scale should be between -100 up to 100, right? This is the maximum that it should range, okay? So watch out, because it could be that, okay, wow, This difference is, there is a big difference, but in principle, that difference is not that big, okay? So let's rearrange everything in order to have the real range, which is the one that is expected, minus 100 up to 100. Can you see that it's pretty flat? Okay, so there are no differences in terms of PISA score regarding maths, boys and girls. 15 years, okay? And basically what we can do is do the same, but in that case, for the science results, I'm going to go a little bit faster, okay? But exactly what we are going to do is exactly the same. So subset the science one and, well, see if there is enough representation between boys and girls. We can see there is also 280 in both cases, so everything seems to be fine for our analysis. The timeline that we have is also, well, the same one. And if we are calculating the mean score, considering each of the subjects and each of the, let's say, years, because we have different countries, remember, this is the values that we have. And if we are seeing, let's say, this information, we can see that also, well, the bars are pretty similar. No differences can be seen, okay? Let's repeat the same process, but in that case, calculating the difference because it's more powerful and, well, we can get more insights from it. And if we are visualizing or trying to visualize those differences, again, we can see that maybe, there are like some weird things here, but again, have a look at the scale, okay? The scale, it shouldn't be that one. If we are rearranging everything into a range that it should go from minus 100 up to 100, this is what we are getting, that the difference is 0, okay? So, well, this is the last thing that I wanted to, let's say, highlight. No? Are we sure that this gap in technology is a matter of the people gender? So the people that, well, this is my message, that stop imposter syndrome, because, well, there is no evidence that girls and boys, perform different, or you are not good at maths or science or whatever, okay? And, well, spread the voice, and if you want that information, well, I can send you the link about everything, resources and so on. And I believe that, well, if you enjoyed this class, and, well, if there is any question, just feel free to go ahead, okay?
Yeah, this presentation has gone very fast, just to have an idea of what it's about. And then Idoia is going to share, we are going to share some kind of link if you want to test it at home and see that it's real what the numbers say. Yeah. Okay, or test with another data set or something like that. Okay. Questions or impressions that do you want to share with us?
So two errors that I found is that you only took this. It's okay? Can you hear me? You only took the data from one source.
It's difficult to find data from the. I know. It's super difficult to find information. The point is that it's super difficult to find information regarding gender. Super difficult. That I was super difficult. And the only source that I found, it was that one from the States. Yeah, I know that it's kind of biased, but try, if you find a data set with information that splits everything into gender, please tell me, but it's super difficult. I know a lot of different sites, Kaggle, and it's almost impossible to get. We see it's super difficult, right? But if somebody, it's not because it was like a mistake, it's because there is no data. It's not, I don't know if it's not interesting or the governments don't want, or no sé. In l'Ajuntament de Barcelona, there is data as well, but I think it's only focused to Barcelona, so it's not kind of worldwide. But in Open Portal, yes, and yes.
And, well, the other error that I found is that there is missing full-time and part-time workers separated from female and male.
Yeah, well, that's the data that I have, yeah. But yes, sure, it's true.
Thank you.
You're welcome.
Other questions?
¿Encontraste algún gap en qué es lo que le gusta o en dónde le ha ido mejor las mujeres en la parte de estudio? Si bien en matemáticas estaban similares, ¿hay algo en que destaquemos las mujeres o siempre igual en general?
Yo lo que vi en los PISA, o sea, porque claro, estos son resultados que hacen a los niños. O sea, fue esto, que no había diferencias entre la performance en cuanto a matemáticas y ciencia, es decir, que no eran ni mejores unos ni otros. O sea, ligeramente había algunos años mejores los chicos o las chicas, pero no había diferencias. Para mí estas diferencias son muy pequeñitas, ¿no? Se tendría que hacer un análisis más profundo, quizás sí, a lo mejor por países, seguro que cambia, pero así como overall speaking no vi ninguna diferencia. Tampoco analicé ni reading ni writing, porque me quería centrar solo en la masterclass. A lo mejor allí hay cosas, a lo mejor, ¿sabes? Claro, yo usé fuentes que había publicadas y de allí pues saqué lo que de esto. Pues seguro que hay.
Suele haber un poquito de diferencia en comprensión.
En comprensión, ¿verdad? Sí. Pero no la analicé esta yo. Porque digo, no voy a ir por las ramas.
Pregunto para entender por qué a veces las mujeres eligen más otro tipo de carreras, no están tech. Quizás porque en la escuela les va, no sé, va mejor en otras.
Yo creo que es algo social, o sea, porque aquí se ha visto, ¿no? Porque en cuanto a performance, te hacen o sea, creo que es algo social, ¿no? Que te van, no sé si desde pequeñita o a medida que vas creciendo, ¿no? O las generaciones, creo que es más algo social. Lo que la publicidad en Instagram, todas estas cosas, ¿no? O sea, publicidad en Instagram, uñas, no sé, como que todo está muy targeteado, ¿no?
Falta
Y
de referentes.
falta de referentes, falta muchas veces, femeninos, esto falta mucho. Mm.
Bueno, yo tengo una teoría personal sobre el tema. No, porque claro, siempre me pregunto, bueno, yo estudié telecomunicaciones y yo nunca tuve ninguna sensación de que no era mi sitio, ¿no? De que no me gustaba, de que no era para mí. Incluso mis padres, todo lo que se rompía en casa me lo dejaban encima de la mesa para ver si lo podía arreglar. Cosas de electrónica, ¿no? Nunca, sin ser muy gente moderna. O sea, mis padres ahora tienen 80 años, o sea, no es que fueran súper modernos, pero tengo la intuición que hablando con gente, entramos así como de refilón. Muchas de las mujeres que entramos en tecnología tenemos hermanos que tenían un mecano al cual le robábamos. O sea, seguramente la tecnología no entró comprada para nosotras, pero aprovechamos el Lexing Castillos, el Lego, el Mecano, y en ese momento supimos que nos gustaba. Yo creo que el problema es que a lo mejor no se ha tenido la oportunidad de probar ni siquiera. ¿Cuántas mujeres conozco yo que han hecho, yo qué sé, filología y después, ostras, cómo mola, ¿no? Lo de la programación, y que han entrado por biología, que han entrado por medicina, porque nunca han hecho un curso de programación, porque nunca se les ha comprado un robot para programar. Comprad cosas, comprad cacharros. Y creo que, claro, bueno, no sé, me da la sensación que cada vez hay menos chicas en tecnología. Es mi teoría personal, a lo mejor me la compráis o no, pero lo de tener un hijo único, a lo mejor aquí el hermano que le comprabas el robot, el hermano que le comprabas el mecano, ahí se está perdiendo un poco el que os lancéis, que la apuntéis, que luego le gusta ballet, pues le gusta ballet, pero a menos que hayan podido escoger. Y aquí ya mi filosofía. ¿Vale? Muchas gracias. ¿Alguna? Ya no voy a contestar más, venga. Venga.
And the next speaker will be Susana, which he will present an organization that, well, as regarding this theme, well, she will tell us. No spoilers.
Llevo varios días pensando cómo empezar esta charla, la verdad. Estaba intentando buscar un chiste como un poco el cortante, ¿sabes? Como estoy en el medio y va a ser rápida, pues digo, bueno, pues soy como el cortante de un restaurante cuando empiezas con el salado y luego acabas con el dulce. Pero es que todo el rato me venía a mi cabeza una imagen de hace unos cuantos años, no muchos, la verdad. Estaba estudiando ingeniería informática, fui a uno de mis primeros exámenes, programación estructurada y modular, pero esto ya es otro tema. 250 personas. Miento, 249 hombres, una mujer, yo. Como podéis comprender o como podéis entender, para mí hoy es un día muy feliz. Estoy muy contenta hoy de estar aquí, porque después de estar años ya asistiendo a conferencias, meetups, incluso participar en alguna de ellas, hoy es el primer día, la primera vez que vengo a un Pyladies, ladies, y que hago una charla delante de tantas mujeres. Gracias a la organización por darme el espacio, por favor. Había buscado unas cuantas cifras para empezar un poco a decir qué hago aquí. Bueno, pero Idoia me ha hecho un trabajo estupendo. O sea, me ha hecho la intro genial. Gracias, Idoia, ha sido una charla. Como habéis visto, las cifras para las mujeres en muchos sectores, sobre todo tecnología, no son muy favorecedores. Y entonces, pues hoy he venido a presentaros este forward. ¿Qué es este forward? No me trae el cacharrillo, así que tengo que ir a la mano, ¿vale? ¿Sí? Creo que no me funciona. A ver, porque me ha preguntado. Me ha preguntado, le he dicho que no, que quit. No, da igual, son 4. No os preocupéis, yo le doy. Este forward, perdonad. ¿Qué es este forward? Pues una organización sin ánimo de lucro, creado por y para mujeres, cuyo objetivo es ayudar a las mujeres a introducirse al sector de la tecnología. ¿Quiénes somos? Pues ahora mismo somos 40 mujeres de muchos perfiles, frontend, backend, full stack, product managers, tech leads, infinitos, todos los que se ocurra relacionados con tecnología, que a través de muchas cosas intentamos ayudar a las mujeres o ayudar bueno, sobre todo a mujeres, obviamente, porque es para mujeres, a que se introduzcan en el sector de la tecnología. ¿Qué hacemos? Mentorizamos. Hacemos muchas cosas, hacemos charlas, hacemos blogs, pero sobre todo mentorizamos, ¿vale? ¿Qué es mentorizar? Acompañar, guiar, aconsejar, apoyar, apadrinar, impulsar. Nuestro objetivo al final, lo que nos hace felices, es cuando alguien de nosotras pone somos una más en el sector de tecnología. Hay una full stack nueva, hay un backend nuevo. Entonces, el objetivo de la charla, sobre todo, o el propósito, es que conozcáis este forward y que si tenéis alguna amiga, si tenéis alguna conocida, si la prima de la vecina del cuarto, si vosotras mismas queréis, pues, o sentís que necesitáis ayuda, queréis introduciros al sector de la tecnología, queréis dar un paso más allá, entrar, quiero ser mentorizada, rellenar el formulario y contactaremos con vosotras para ayudaros en lo que necesitéis. Muchas gracias. Perdonad, si tenéis alguna pregunta en el networking. Olga, ¿levantas la mano? ¿Hola? ¿Levantes la mano? Vale, por aquí estamos varias de este forward. Si tenéis... sí, estaba despistada. Si tenéis alguna duda o lo que sea, podéis contactar con nosotras luego, ¿vale?
Vale, yo digo, pregunta.
Perdonad.
¿Alguna pregunta mientras se prepara la última speaker de la noche? Bueno, aprovecho para decir que Adevint ha preparado como un panel del 8M para saliendo de estas charlas, si os da alguna inspiración que tengáis, alguna cosa relacionada con el HM, alguna charla que os haya inspirado, algún feedback, hay un tablón con post-its si queréis compartir con la gente pues vuestra impresión. ¿Vale? Y damos paso a Marta.
¿Esto va?
Pruébalo. Y va, en algún momento te ha ido. ¿Prueba ahora? Sí.
No.
Ahora. ¿No?
No, maybe it's this. Yeah. It's okay.
Espera. Ya está.
Okay. So I will be talking about the analysis of a web page called Queer the Map. You can check it out. Sometimes it loads very slowly, but it's very interesting, and I advise you to take a look. First of all, I'm going to introduce myself. I'm Marta García, Maña, living in Barcelona. That means that I'm from Zaragoza, which is a city that it's 2.5 hours from here by train. I'm the mom of Eli, that I will be presenting in a minute. I'm a medical doctor in preventive medicine and public health. I'm one of those women who changed careers. I'm halfway through the cross-platform app development vocational training, and currently I'm open to work data analyst. And this is my little tiny queen who doesn't help much while I'm programming. Sorry. So yeah, this is how it looks when you open the Queer the Map page. It's basically like a Google Maps where you can add a marker and add a comment to it. So the idea behind it is that it is community generated, and it's a cartography of the whole global queer experience in a time when we are still being silenced or hidden. So the idea behind this webpage is to preserve our stories and realities. And one of the questions that arises when looking into the webpage, in the info of the webpage, is how do the multiple inequality access, meaning race, gender, economical background, sexual orientation, anything that you can think of that in medicine we call social determinants, how do these multiple inequality access affect the ways in we as queer people create space and relate to it? So web scraping this web page, I could only find the comments and the coordinates. That was all. I didn't have even a timestamp. That was it. It was in a file similar to JSONs, and turning them into JSONs, that's how they looked like. So as you can see, there's the latitude, longitude, and then in the description is the comment. So I wanted to analyze things with just the coordinates and the comments, and this was how I planned to do so. So after web scraping, I wanted to describe the web, which countries were most populated with comments, the languages used. That was going to be important to do the analysis of the discourse, and if there were any geographical clusters in each country. And then describe the discourse using the NLTK library from Python. I don't know if you're familiar, but I found it quite limited. The length of the comment, thinking that if a comment was very long, maybe the person really wanted to share that. So it would be like an approximation to the intensity of the emotion shared in the comment. And the words used. I created another metric, emotionality or intensity, taking into account the length and the limited information that the sentiment was giving me. And then I created a Streamlit web page with Python to show the results of the description. And then I tried to answer the question that arose in the info of the web page. That was, how do the inequality access relate to the discourse? In this case, what I wanted to look at is variables that, according to a very quick medical literature review, were linked to transphobia and homophobia globally. So I wanted to know if those variables were related to the discourse in this web page. So first of all, the description of the web.
As you can see, USA is the one that has most comments. This is a Canadian webpage created in 2017. And it has, that number is almost half of all the comments that are in the webpage are in the USA. I didn't add it here, but in fourth place is a country called none or null, and that's because a lot of coordinates were in international seas. That's weird, but maybe people don't want to share where they are. Maybe some of the comments just said this sea separates us, or they are political comments that aren't linked to a particular location. But yeah, a lot of people don't want to share the location. And 95% of all the comments were in English. This is again an approximation because I used different libraries to try to be able to define the language. It has a lot of slang or abbreviations. So, but it gives you an idea. And this is very important because the sentiment analysis would only work if the comments were in English. So a lot of the comments are in English. And this is the geographical clusters. This is how the Streamlit webpage looks like. And as you can see, the different colors are different clusters. And for example, in Spain, you can see that Catalonia, Madrid, Valencia have different, and Galicia have different colors, meaning that obviously most populated areas are most used in the webpage. Now the description of the discourse. So first of all, the sentiment, I already said that it was very limited. The sentiment analysis gives you, is an index from -1 to 1, and the 0 is neutral, the neutral component. The library was only being able to gather the neutral values of the comments. It wasn't able to differentiate between positive or negative in a lot of comments. This was a limitation from the library, but if we don't take that into account, we can see that people tend to use the web page in a positive way. More people are in the positive area than in the negative area. And when you look at them, a lot of the positives are not really happy experiences. They are just positive. But if you look at the negatives, there are stories of trauma, abuse, they are clearly negative. And now the emotionality. This is the metric that I invented because I didn't trust the sentiment, but I didn't want to just throw it away. So it's just the multiplication between sentiment and the standard of the length, but taking into account the negatives and the zeros. I only wanted the absolute values of the sentiment and to erase the 0 from the multiplication, and I added 1 to everything. So this is the distribution, and very few people share a lot, write whole Bibles in the webpage. And this is the distribution without the outliers, but I haven't put it here, but this distribution is quite similar to the length, actually. This is how it would look like in the Streamlit. So the minimum emotionality, for example, well, in the world are 2 vegetables because we love veggies, apparently. And in Australia, the minimum would be this whole story about PTSD and so on. And the description of the words. So in the world, we can see the first love, time, and came. And for example, in Spain, we can also find first love, time, no. And this repeats across countries. This gives us an idea that what people want to share are coming out stories or first-time experiences. And now the analysis. Please take everything that I'm going to say from now on with a grain of salt, okay? These are the variables that I found in the literature. I can talk about them particularly, but so that you have an idea. Some of them take into account the political context, the education, the health, the economic background, and specific for the LGBT community. And I'm going to show the ones that showed a significant association with the discourse and the emotionality, but only if they are quantitative, because it's already weird, the results, and it's very hard to explain and understand the results with the categorical variables, okay? So maybe now you understand why the results are weird. the positive sentiment is linked to political stability, good same-sex act legal status, and having homophobia as an aggravant for hate crimes. But it's negatively linked to health coverage, to antiretroviral therapy coverage and universal healthcare coverage. This for me doesn't make much sense. And for emotionality, that is not positive or negative emotionality, that is intense emotionality or numb emotionality, you find similar results and also very weird. If this was an article, the discussion would be larger than the rest of the article. So the discussion of this is why are we finding this kind of association? And maybe it's because, as we have seen with the sentiment, people want to share just nice and positive stories. So that's not going to be linked with your context. You want to share good things. Another thing is that queer experiences might be much more linked to the community than to the country characteristics. So if you are being supported and you know that you are protected, your experiences are not going to be the ones that would be defined by the country itself. And another reason is the handling of missing values. There were a lot of missing values, and I didn't have the time or the proper computer to do anything but simple imputation, grouping by the categorical variables. And that's very limited. It's better than not imputing at all. But yeah, so that was the analysis, take it with a grain of salt. And it made me think of actual relationships that we couldn't see just looking at the World Bank variables. So the conclusion is that sometimes we think too much about the best algorithm or the best regression model, when sometimes the what you need to know and what you want to know is right in front of your eyes. And for this webpage is that the most repeated words are love and fast. So the most important thing from the analysis of this webpage was just a count method. As I said, this web is mainly used to share experiences and coming out stories. And when we enter into the analysis part, things start to not make sense, really, because maybe we are not asking the correct questions. And to end, the limitations that I found, this is a Dalek. This is the name of my computer, actually. When you enter into the terminal, I see the Dalek. And it's not that it wants to exterminate me, but sometimes it's not very helpful. So I would have loved to do some entity analysis to know if people talked about politicians, certain people, certain locations, but it wasn't just possible. The handling of the missing values was also a limitation, and the metrics limitation that I mentioned with the sentiment analysis. And again, this is me if you want to connect to my LinkedIn page. And now I have to the web page that I created, the Queer in the Map web page, and to GitHub repositories if you're interested to. They are here if you want to.
Well, thanks for the presentation. It was super nice. Just for curiosity, which were the languages that were not English? Just Spanish or?
Well,
curiosity,
I cannot say it, but I think that French and Spanish were the next ones. But you also have Greek, for example.
Oh.
Yes, so. But I don't know the number. I don't,
because there are some libraries as well in Python in which you can translate, no?
I tried to.
There are like the limitations in terms of tokens o no sé qué, pero...
Yes, yeah, and I could translate very few.
Sí, es que es lo que pasa.
Yeah. So I thought, okay, it's just 5%, just forget about it. Yeah.
Cool, thanks.
Hi, thank you for the presentation. What a fantastic project. I was just curious, did you look at the the comments that did not have a country or that had were from the middle of the ocean, if they had any like particularities or characteristics.
I just look at them like, and that's what I said, that some people just share the story,
Yeah.
but they don't want to share
Yeah.
the location. A lot mentioned this is what separates us, or I remember the last time that I went, blah, blah. So yeah, and other times they're just silly, like, I like to fuck, so.
Yeah, I was thinking like if they had a specific like sort of sentiment, like the people who don't give their
Yeah, I
country
don't.
or are in the sea. Yeah.
Yeah, I didn't check that.
Yeah. Okay. Thank you.
But in the Tableau, in the Streamlit webpage, in the graphs, you can look if the sentiment is very red or green, and yeah, it would be visually analysis, but yeah.
Awesome. Thank you.
Okay, thank you very much, Marta.